volume is huge, speed of data generation is huge, and then variety of data is huge. Okay, so this variety, and then you can say like speed of data generation, and then volume of data generation. So it's huge. So this is good for like deep learning is good. So good for when you have to engineer. Why? Because you are not modeling by yourself. It will learn by itself. Okay. So these are some success stories of AI, like Deep Blue computer. This is for for chess. It beat I think Kasparov. He was the the world champion at that time. Okay, and then natural language processing. ChatGPT is one of them. Okay.
Is this a natural learning process?
No, this is natural language processing. Natural language processing. Yes. Okay. And then this slide is a bit important. Let us give it. It will give you a bird view what we are tackling. So in machine learning, you see unsupervised is like clustering. So in the clustering means I don't have, say for example, we don't have no level. No level means I don't know what is the output. I have only the data. So what is happening when you have huge data? Say for example, here automatic design of traffic zone. Okay, you want to traffic zone, you can do it systematically. Okay, this is one traffic zone, this is another traffic zone. But in another way is that you put out the information. This how many trees generated, what kind of what is the land use type, and you put it, and then let it decide. So it will do the clustering. So clustering means you will try to clustering has only one one principal idea. Cluster, the member of the cluster will be close among each other, but far away from another cluster. As simple as that. All the clustering technique has the same idea. They will be close among themselves, but they will be far away from another cluster. Okay. So by this way, you can say that okay, how many clusters we should. So this is one cluster, this is one cluster. So if the system will find out, so this is the technique: k-means clustering, subtractive clustering, hierarchical clustering, self-organization, self-organizing map, fuzzy k-means. So we'll touch k-means, how to use that. If you have the intuition, how to use that.
Is the clustering means the haphazard of data? It organizes it in such a manner like K means subtract.
Yes. So if you find out, you see, for example, they're like I gave the example of traffic analysis zone, for example. So traffic analysis zone you can by yourself, but you found you have information. You don't want to do it by yourself. You want to make it in like what the data is saying. So you know how much it will be generating, how much population is having here, what is the classification of land use here. Okay. So usually traffic analysis zone we want to make it as a homogeneous. Okay, but you have a 7 10 variables probably, so it's very difficult to like homogeneous. So you might guessing, but let it decide. So what it will do, it will say, okay, this area has homogeneous characteristics. So one cluster, this another area they have homogeneous characteristics. So this is another cluster. So I'm not deciding myself, but you can, if you go deeply, what you can do, you see, should we make a 3 cluster, 4 cluster, 5 cluster? So you can find out some criteria, find out that this clustering are great, some indicator. Okay, fine. And classification and equation problem. So here you can. This is called supervised learning. When I say supervised learning, we are giving the output level. So we divide the data into two categories. Split the data. Like one is, for example, traffic flow prediction. So for traffic flow prediction, I will use the data for say 1 hour. Say 15 minutes interval data I'm taking. Okay. So I will take say 15 minutes interval data. 15 minutes. Okay. Interval traffic flow data. Okay. I take 2 hours. So I have 8 data points. Input 1 to input 8. Input 8. Then my output is say next 2. So next 2 means output 1, output 2. So I am using say whatever 200, 300, whatever, and then here I will get this 2 output. Okay. So I will arrange the data like this, and then I will split the data. This is training, and this is testing, for example. What does that mean? My model will be developed on the training data. My model will be developed on the training data. Then I will not show him the test data. Then I will just evaluate him for the test data. So what I discuss now, this is called machine learning workflow. Machine learning workflow. Okay, we'll come to that. So anyway, this regression problem, as I mentioned, classification regression problem. Classification problem, the output is like category. But in the regression problem, the value can be real value. Okay. Reinforcement learning, this is like, this is a bit separate. We are not going to we will not discuss too much about that. Because reinforcement, like a robot you put in a place, so it's unknown environment. So he has some basic information. If he get, if he get obstacle, it will take some measure. It will go back, it will time back. But if it does not get obstacle, it will keep going. So there are some simple. So this is one of the approach, reinforcement learning, or that would be agent-based learning. Like small, like you can say that it's like a small agent. They have some basic, they're not very sophisticated thing, but they like a robot. They will communicate, and then they will take their measures, and then the new pattern will result. So this one is used, but we will focus on the other part.
Doctor, do robot follows the supervised process or?
No, this is reinforcement. Reinforcement means if he is doing great, he will get reward. Okay. Say for example, you can make like this: that okay, if he is not getting obstacle, he will increase his speed. Okay, so it's a reinforcement. You are reinforcing. But if he is obstacle, he will slow down, and then he will take a specific time. For example, so this is reinforcement learning. You are reinforcing. You are doing good, take like a word. If you are doing bad, take different negative feedback. So here, machine learning methods, you have individual model in artificial neural network, fuzzy logic-based system, and then deep learning is part of that. One is the hybrid system. Hybrid system, we are talking maybe multiple models together, like neurofuzzy system, genetic neurofuzzy system. It could be many. So how they use this, like will come. Say let's get a bit familiar with the with one of the model, then we understand. So optimization, for optimization you can, this is meta heuristic basically. Okay, genetic algorithm, particle zone optimization. Let's get some concept which is important for us here. This is low bias. We want to make sure that we have low bias and low variance. Okay, or another way, we want to say that we want to get the model which is having good generalization capability. When I say generalization capability, it means it understands the training data sufficiently, okay, so that it can predict new data. If you give the new data, it can predict better. This is not better. It can predict well. So in that case, you see here, if this is the training data, what does it mean? Do you have any clue? If I am saying the training data, this one, and this one, how do you rank them? Read this terminology, bias, variance, limit. I put you 3 models. Okay, these are the original data, and the model is the for example the line, solid line. Okay, so Iman, how do you define this model, this model, this model? Good, bad only. This red is the data point, say x and y axis. This is the and the relationship the model is giving. This is like this. Okay, say quadratic function, and this is giving higher order function, and this is straight line. So how do you take this model, the first model, good or bad? Good. What about this one? Why? But you say bad, no problem. What about this one? Which one is good? This one or this one?
Number 3.
This one is good or this one is comparatively? This one. Intuition, no need to explain. What about you? Which one is the best?
I think number 3 is best.
Number 3 is the best.
It can separate the.
No, not for explanation. What do you prefer now? You prefer this one. Okay. But this is a regression problem. This is a regression problem. So you're thinking that this is the best. Okay. Okay. Why you are thinking this is best? You said?
Because it can separate the data. Suppose.
No, it's not classification problem. It's a regression problem. We want to predict if x is like this. You see, try to understand the problem. This data is saying if x is like this, output will be red is the original output, but the model will give something here. You understand? Here it will be clear. For example, if x is somewhere here, you can follow. Original output is red one, up. Okay, but the model will tell me this is the output. I will give you an extreme example. You come here, like last one, last window. model original output is here, but model will say this one. You understood that? Sure.
Can you repeat it?
Because this is the model. I'm saying the relationship. This is the original data. I got now function. This is the function. The relationship. You got the point. Because I don't have, based on this data, I have made a model. Okay, this is a quadratic function. And this is like any higher order function. And this is a linear function. So linear function means for any function. For example, if the value is here, like, let's make it like this. This is my original output. For this x, output is this one. This is clear? Yes? But the model I developed, if x is here, the model output will be here. Because this is the model. Clear?
Yes.
Yes.
Predicting the value out of your keeping the data, predicting it for enough.
No, this is for training data now. I gave the data. Based on that, he is trying to learn. Okay, and he learned it this way. He can learn in 3 ways. This way, this way, and this way. So what is happening? Here, I can say he is getting the general idea of the model. He has good generalization. If you have new data, you see he will not do bad. But here, he is memorizing. He is memorizing. He doesn't have any generalization capability. If you put new data, it will have very difficulties. Because he is learning what the data you have. He just memorized like a child. There are 2 options. He just memorized the example you gave, that's it. But new data he will not be able.
How could we understand that whether the model is learning the process in this stage or whether it's generalized?
Yes, this is a great question. How you learn? When you see the test data. What I'm saying, I'm trying to give you intuition. So I build the model. You can build this model, and this model. What will happen? This model, training error would not be that much. This one, training error can be 0. But testing error will be high. And this one, training and testing, both error will be high. And this one, training and testing error will be moderate. This conclusion you agree or not?
Okay, so the first one is better than the parameter.
Sure. This is the best model basically.
Okay.
Because he understands the relationship is the quadratic. The relationship is really good. But this one, he is doing 2 months. And this one, he did not understand even the relationship. Clear?
Yes.
So here what is happening? We are separating the data. Training data we are using to build the model. Testing data we are using to evaluate the model. So this is the workflow. You get the data. You can sometimes they will say that let's say that feature. You get the feature. What will be the input? What will be the output? And then the next step is what you call you split them, training and testing. And the training, 3rd step, build the model. And 4th step, evaluate. Then if you are not happy, go back. What you can do like you can do some steps. I'll tell you in a bit, like machine learning features, like what you call when machine learning workflow. I will discuss again slightly. So classification problem in binary or multi-levels. Feature engineering. Feature means selecting the inputs, which are important for this model to make the classification or the regression. And then sometimes we use feature directly. We can transform them. We can, if there is missing, we can impute feature scaling. We can make them all of them the same scale. Let's come. So these are the steps. For example, data collection, data processing, build a model and training, evaluate the model. If the performance is not satisfying, deploy on the real system. Okay. By the way, we will use machine learning when like if the physics of the problem is not well known, or it's very difficult to get the data. Then we will use the machine learning in general. Okay, there is some how can you model selection? Which model you should take? Which model you should use? So there is some what we call there are some performance measures. Okay, which you should consider. Okay. See here, training, validation, and testing. K-fold cross validation. This is like you can say K-fold. I'm saying training and testing separately. Okay, training and testing separate. But you can do some other things. K-fold cross validation. This is a bit advanced. I will tell you, but it's a very simple thing. Okay. And this for classification performance measures. Positive, I like what you call. This is confusion matrix. You just see searching confusion matrix, you'll understand. For classification, you can see accuracy. Okay, clustering. Say we discussed slightly. Partitioning, this is the main idea, like how you define, how you make them, what you call, how we separate them in a cluster. Here is one simple example. So let's get familiar with k-means. This is a clustering technique. Okay. Users set up the number of clusters they would like. Say here we want to start with k is 4, 5. Means 5 cluster. So you start any random number. Then you put here to randomly. You want to cluster them. So randomly guess k clusters center locations. Okay. You just randomly. Then okay, let's read and then try to understand, explain. Who can Iman or Mustafa? Yeah, third step, can you explain? Read it and explain. What do you understand from 1 to 3? Okay. This is a technique for clustering.
Suppose there are some points in the figure.
These are the main points. Okay.
Red points, like.
No, the blue points is the original data. Okay, then
Random values that will be the center. And then the machine will have to go around and check which values are closest to this center, and then they will cluster them together.
yes, exactly. Yeah. So you see, this is the division he's doing. This point are close to this one, this center. So put them in he is the owner of these points.
Yes.
You got the point? So this guy is the owner of all these points. This guy is owner of all these points. And he is owner of this point. Means he is the center of all these points. And then, okay. And the fourth. Then you take the Euclidean distance. You find out their center. Find out their center. You just take, for example, all the points, take their average. So you found new cluster center. Follow me? You explain. So what is happening? In this fourth step, what is happening? Number 4.
We should the center because the old one is not a real center for this data, so we should do it.
Yeah, Masha. And then?
I think you will keep changing the circle as you find
Defines the center.
Yes, exactly.
And just
So it's like, so you see, here your intervention is not there. Even it can, so what will happen? So finally you get the clusters.
is the accurate.
Yes.
Define the center.
But there I am saying only 2 dimension data. Your real life data, we say 7, 8, 100 dimension. So it will be affected a lot by the starting point. Which random variable from where you have taken. Okay, so it will be affected by that. But anyway, so you learn one clustering. You can say that? Yeah, you can say what is k-means clustering? Yes?
Yes.
That's it. Okay. So till now, okay, we learned one thing, it's done now. Okay, what else? Till now, what do we learn? Yes.
The methods.
Yeah. Other than k-means, okay, what do we learn? Yes, tell me.
We learn the methods of how the machine follows through the curves.
Okay, like a good model, bad model.
Yes.
Okay.
Supervised
Overfitting, underfitting. Okay, supervised,
and so
unsupervised.
and also
Classification,
reinforcement.
regression, and then reinforcement. I will ask the same question. By the way, I think this slide, my colleague, Sarah, she added. It's like I gave him my old slide. I said, okay, give it to her. So she added that thing. Okay, this is interesting. Decision tree. Decision tree is a machine learning. You can say the algorithm. Here the idea is very simple. Okay. Decision tree is like, the idea is that, say, if we stick to the problem of crush severity, when the crush will be severe. So first is that we have severe and non-severe is 50-50. So what you can say, all are severe. So what will be my mistake? Say I have any data set. 50 is crush data, I have crush related information, like who are involved in the crush, what is their age, who is driving the car, and then what is the vehicle type, and how many vehicles are involved in the crush. And then this prediction is it severe or not severe? I have the same number of crash, what do you call it? This is like, severe and non-severe, the same number. So if I say all crashes are severe, what will be my mistake?
for data, I divide by what?
What I'm saying, crash severe, there are two. I said all of them is severe. So what would be my mistake? 50%,
Yes.
isn't it? 50% I am correct.
Yes,
Clear?
yes.
So this is the this is called, you can say, any step we do, we want to be better than that. Okay, we want to get some more gain. So this is the we defined it. Okay, if someone is an old man, his age is so we found that if someone age is more than 60 and he is involved in this crash,
Then age will be the main factor.
probably you see that the crash could be severe. So now you gain some. Okay, you get some more information that okay, if maybe 70% cases this is true. So what is happening? You are gaining some information. What you call gaining for prediction. So you will buy this decision one. So you will make some. This is the decision. You will make a decision. A condition. You make a decision. You will go here and there. But this is at the final stage. It will not be decision. It will be condition, and finally this is a decision. Like this is the type of, for example, severe or non-severe, severe, non-severe. Okay. If you see methodologically, if you ask very systematically, what does it mean? This is, they call it root. So from the root, you can have branches. So these can be branches. These are branches. Okay. This is the root. These are the branches, and then these are the, you can see what you call, these are the nodes. Okay. But this one will be leaf. When I am decided, that's it. I am not gaining more gain. Because here I already found out, all in crash, and this is severe and non-severe. So this decided, so I don't need to go down. Okay. And then this is depth. Depth is like this one. 1, 2. You can follow this. This is the 1 and this 2. So depth is 2. Okay. So this is the decision tree. Okay. Decision tree a bit you can follow intuitive. You have some feelings what is going on. Okay. So this is one of the techniques. So you can easily implement that. Okay. But just to encourage you now, let's do some motivation. So motivation is that if you want to implement machine learning, there is one very easy path. Easy path is that there is no coding. There is one approach to get the flavor. Do you enjoy that? Do you really feel that there is something? So there is some software you can try. For example, one is Weekend. And then there is one is D-Track, and Neural Designer. I think Neural Designer. And another one. It just came in my mind. Usually for our graduate student, we push them in the Python. We said, okay, if it's like an MX program, I will say that only I stick to here. But our graduate student is okay, because we are expecting more usually. So Orange, there are other software also. You can be on the long back, but I really personally use Python and Method. But I think D-Track is also interesting, Weka is also interesting. Why do you use that? To enjoy it, basically. You put the data, and you can see the classification regression. So you can feel it, because initially it's important to understand what kind of problem you can solve. Okay, so if I tell you now, okay, you are familiar with Python? But Method? Okay, Method. What the? Whatever you. Method Python?
Intermediate.
Sorry?
Just learning.
By the way, this graduate research, at least take one software. It's really Python is better these days. Python, but Method is also fine.
We do it as part of our courses, or we learn it.
Sorry.
We do it part of our courses, or we do it separately.
I would say that define the problem. But generally speaking, if you are in the research area, you have to it's up to you the way you prefer to learn. But it's good to have at least moderate what you call skill in one programming language. Okay, so especially like Python or Method, whatever you use. And these days, I'll tell you, believe me, just to if you spend 20 to 30 hours, sincerely. Concentrate, not like, not multitasking, not there are multiple, it will not work. Concentrate on one word, really 20, 30 hours, any language, you will have a general idea. So what you need to know? You need to know how to import data, how to visualize data, how to do statistical analysis, and then how to do modeling. And what are the ecosystem, what are the framework, what are the packages in general. That even you can use, if you know up to this 30 hours, believe me, you can use even ChatGPT, you can use GPT-3 to write code for you, and then you can just tweak here and there. Or even literally, even you can just actually understand. But if you don't spend 30 hours, then you will spend a lot of time fixing small problem. You don't need to memorize, but you don't need to memorize. But keep learning, it's really delicate. You see a fancy curve. So why don't you just change it and then use your own data? You got the point. Okay. So this kind of thing, if you have, I'm telling you, 30 hours, you'll see a big change. After 30 hours, you change a big change. And discuss with your colleague, friends, see how the ideas they're doing, and then by the way, somehow link it with your MS thesis work. Otherwise, learning will not help. If you don't have an objective to learn, don't learn it. If you don't have something that you want to solve that problem, for the sake of learning, it doesn't help. At least this, no need. You can learn. So here, okay, you have just to motivate you to get engaged, you can try those kind of things. Okay. So this decision tree, by the way, is the code is maybe a few lines, even in Python. Okay. So here one problem, classification problem. If you have which drug you have to use, look at the blood pressure and then the gender, and then you make a decision. As simple as that. So there is some pure node, impure node. Is there? You just have to spend small time. You'll be able to understand. Like this is impure. Okay, because here still we are not getting rigid answer. Okay, this is based on the data, by the way. We are training data. For testing data, he will make a decision again. He can be right or wrong. Okay. So now, what do we learn now? We learn
K algorithms.
Sorry?
K algorithms.
K-means. It's called K-means. And then? What? Sorry? Yes.
The model selection techniques are claim validation.
Now tell me, do you have any problem in your mind which you think that maybe is somehow related? 2 minutes. No problem. Do you think that, I'm saying that the courses, you took only 2 courses. How many courses you have taken?
Taken 3 courses.
Total 3 courses. Okay, so any
Right
course
now or first semester also.
First semester, how many courses, graduate courses you have completed?
I have completed with 3, now it's 6 going on. 3 going on.
3 going. So you completed 2 courses. Oh, you are just the first semester. Not mine. So, but you have anything is coming in your mind? This problem could be solved like that, or this problem is classification problem. This problem is regression problem. Anything?
I think that now for 571.
First one, I want explanation for me.
Yes, I am doing a term paper on how the third generation will be changing.
How?
The third generation
Yes.
will be changing because of the online shopping. So we need to do a inclusive function for that. So we do a good project, but I think we can do anything for that.
Yeah, great. So, but do you have the data?
I'm confident with that.
Great. This is a good problem. It's a good problem. You can try with the logistic, and this is like a base model. This is logistic, and then you see, for example, like a deep neural network. See how? Yes, it's a regression problem because strict generation can be any number.
Yes.
Okay, so it's a regression problem. Okay, there is some small tweak, like for example, this one. Okay, that's great. So you have anything in your mind?
Yeah, I think in my same courses, urban transportation planning, I was thinking to implement the autonomous vehicles. So I think these machine learning methods will help me whether it is feasible to implement the problems in the city through autonomous vehicles or not.
No, tell me, what is input and output?
Input will be like
Think of it, not necessarily right now. So, but tell me, what is your input and output?
This is the data.
What is the data?
So I will be given a I am collecting social demographics data, and then I am asking because it will be out for after and during COVID. So I am collecting the data of how frequent they are doing the checks using the online and using the real time. So the frequency of the threats should be related to the social demographics data.
But social demographic data is not changing.
No. Yeah.
You need to have something which is changing with the output. So your output is street generation.
Yes.
Okay. So, but the problem with the social demographic is flat. Is like what do you call it? It's not changing. So you think of it, no problem. No need to solve the problem. But I think it's a good problem. You need to frame it. You have to find out the input which are changing and has a relationship with trip generation somehow, not necessarily cause and effect. This will find. This is a good thing. This is a good exercise. Okay. So you have thinking about problems which could be solved like machine learning. Okay, that's fine. So this is like a general idea about the neural network. What is happening? It was an ups and downs. Sometimes it's very fast, then it's went down for some problem, non-linear problem, still. Anyway, so we'll discuss the model here. This is very simple, but let us understand. The understanding of AN will help you if you are in any time you want to work with machine learning. It will help you to understand the neural network. So neural network, this input is coming here. So this is the input layer. Okay, here we are not doing anything. In the output layer, what is happening? It has like this. It is going. And then we have the weight, we are multiplying that. It's going there, we multiplying, and then we are adding them. After adding, there is a function. We call it activation function. There is input there. This is the every node we have this node we have activation function. It's a non-linear activation function. Okay, and then we are getting this output here. Okay, again the output coming from here. There is a weight. There is a coming from, or you can take it directly also. Then you get the output. Okay. So this is the general thing. It's going this forward pass. Then you are saying you have the training data. You have the output. For training data you have the output. For training data you have the output. So you are looking, is it matching? How much? So if you are saying there is an error, so you will change this weights. And then you try to continue forward pass, backward pass. Then you finally so here you should have a loss function. Okay, so this is the general structure. There are things, other details, but this is the general thing what is happening. Data is coming, and then input data is coming, and it is to. So there are some other minor issue. For example, if you give the same weightage to them, so you scale the input. Scale the input. Say for example, z square. You know the z square. X z square, x minus x square divided by the what you call sigma standard deviation. Yeah. So it's like normalizing the data. Okay. So normalizing the data, they will have similar effect. Okay. And then the weight, this what do you call? So you have a weight. So this weight will be changing finally. When you have a trained model, this weight will get it. This will make sure that it will make less error for the training data. But the challenge will be for the testing data. Okay. Okay, so this we call it neuron. How many neurons you have? So this is the hidden layer, this is the input layer, and this is the output layer. You can, to get a flavor, you can use this software. G-Track probably G-Track is maybe easy to use, probably. Easiest, probably. I'm not sure, probably. Okay. And
are those software free or
for this 30 days trial version, I think G-Track. Wika is free. I think Wika is from university. Orange, probably I think free. Neural Designer is free, probably. Okay. Oh no, it may be 30 days or something like that. But by the way, you can use MATLAB. What do you call? It has some. What do you call? MATLAB has some what do you call? Graphical user interfaces. You do some of the problems say neural network. Probably you can do it without coding. Like you can just select the data. They have toolbox. Sorry, neural network toolbox. You can help them. Okay. You can code and you can also use that. Okay. But I would suggest if you have planning for like a PhD, like a master's, if you by the way, one programming is really helping. And as I told you, it's not like a lot of investment. You need to like do it. And then it will be built on that. You do anything, you can. Python has so many things, for example. So many things you can make it with like a few lines of code. So this is a big opportunity to take. So here, what is happening? Structure of a node. In this node, we have a squash function. So there is a squash function is this like a function, activation function. So it can make the input from 0 and 1, whatever. For the timing, like there is a nonlinear function. There is some kind of nonlinear function. This is a Rahman function. This is a ReLU function, rectified linear unit, hyperbolic tangent. Okay. So there is slight trick, like when you are using for regression problem, maybe you can use some. You can search it. Which kind of activation you should use? Okay. And then if you have classification problem, which kind of activation function you should use? Okay, this already will be. You can just search and get it. Okay. So same thing, feed forward implementing network. Okay. There is some information I will ask. You can see the example now. If you see one example, what is happening? Multiplication, adding, and then putting it here. As simple as it's not really big deal. Okay. But when you have deep neural networks, it will do like there is a learning algorithm. So when we create a bit, say there are different kind of learning algorithms. There are different types of hyperparameters. When I say hyperparameters, how many neurons you should consider? If you say, for example, if you are not using any objective, like what you call optimization technique, what you can do? You start trial and error. Put 2, 3, 4, 5, 6, 7, 8, 9. Then you see how it's working. Then you add another layer, see how it's working. But there one thing, if you have a small set of data, so it will not work. He will overtrain. He will just memorize this. Okay, you need good examples, like a good number of examples. Okay. So now, do you have some intuition about neural network? Some intuition about neural network. What is neural network doing? Some intuition. So neural network. So you can by this way you can learn very complex relationship. Okay. But by the decision tree, decision tree is a bit simpler. It can, you see, if the data is something like this. Decision tree will what will do? It will like break like this. Okay. Decision tree will something do like this because you see if age is like this one is here and there, so it can somehow classify like this. Okay. But neural network even they can make something like that. Okay, you'll understand. So what we learned now till now? Supervised learning, unsupervised learning, training, testing speed, and then what we call decision tree, k-means, artificial neural network. Okay?
ANN fundamentals.
Yeah, artificial neural network. Here, okay. Okay, this one thing, and then we can also try by ourselves this mental toolbox. Mental arithmetic here. Mental. You can. So for next class, what I expect from you, go to the presentation again and see. There is another presentation on Python. Okay. No need. If you are familiar with method, see the method. See one simple implementation. Make your hand dirty. Okay. So at least, by the way, from wherever you work, you see you will encounter machine learning. This is I think almost reality. If you are in a academia or you are in a what you call professional organizations, you'll see somehow you will have some interactions. So at least you take the opportunity, like make your hand a bit dirty, and then you spend some time, and then from both of the presentation, or I shared a book. But this book is, but this is only for Python. But this is give the general. It's not too heavy. It's only 190 pages. It's not that heavy. But if you are familiar with method, I will not ask you to shift language. Method is fine. You just see the similar way. See the one example. Say decision tree, k-means, and ANN. How to implement this? Okay. I'm not expecting that you will completely understand. But any data set, You have a data set, you have input out, and then you implement it there. Okay, search, take the help, and then do it. So if you do that, even you can use here MATLAB Toolbox or DTrack or WeCare, but it will really give you what you call confidence that later in any problem you can use it. Really, I can forcefully. I think you enjoy. Okay, there is another issue. Is I will push you at the end now. How much time we have? Okay, still you have 2 minutes. Okay. What about time series? The time series problem, what we are doing, the time series problem, we can take the output and again put it as the input. How is happening? Because traffic flow condition, say model predicted some value. I will take this value for predicting the next step. So this is called recurrent neural network. Okay. But there are, in the time series, what is happening? If you time series problem, there are many other models. So what I described to you, say a few models I discussed. Okay. So what you can do when you are faced, if it's if you want to contribute in as a research article, journal article, then you have to take an area. You have to find which kind of model you should use, what the people use in the literature. Then you have to enhance it probably. Okay. So now again I will just brief you this one. In the machine learning workflow, I mentioned that you can develop the if I say hyperparameter. Before hyperparameter, let me come. You have model. Unfortunately, the model result is not that good. You try it with say some neurons. When I'm saying that hyperparameter, you just change the number of neurons, number of layers, number of neurons, decision tree. You change now, for example, decision tree there are some parameters. Okay, you change it, but still the model is not working well. So what you can do, you can change the hyperparameters. You can enhance data. Okay, or you can what else you can do? You collect more data, for example. Or you can use, for example, you can try different model. Okay. But here, this hyperparameter, you can try by trial and error. Say, for example, you check by yourself, trial and error, or you can use meta-heuristic optimization technique. Okay. You can use an optimization technique to tell you what could be the number of layers, what could be the activation function, what could be the learning algorithm. You just keep it at the list and you will do that.
Is this the optimization techniques and meta-heuristic are the same thing?
Meta-heuristic is one type of optimization technique. Okay, it's like metaphorical optimization technique. Okay, so it's like some concept in the human human world or say animal world. You take the idea and then make it. By the way, you just need to say for example, generic algorithm. You can say so. I will explain it a bit. But before that, so what I'm saying that you can use meta-heuristic to decide about the hyperparameter. Okay. Sometimes data is maybe not enough for training, so you can collect more data. Sometimes the model is not appropriate, you can perform. So there is another kind of model called ensemble model. Ensemble model, you take many models and take their if in regression you take the weighted average or average. Ensemble model. There is another kind of model. You take multiple models and you combine them. Okay. So here, I've said the problem is the training and testing data. If you have a validation set or training set, for example, testing set, for example, if you do too much training, what is happening? Your testing, it will not do well for the testing. Okay, so you have to somewhere here you have to reach. We don't go too far. We have to make a balance. Okay. I think concept-wise we discussed more. Like, let us say now, what do you feel? Like, not necessarily this one. Okay. This is like ensemble model. Okay. Before that, let us summarize again. So till now, what we discussed. Not this slide. No need. This slide I will explain. I think it's enough. Okay. So, like for next class, what could be the plan? Like I suggest that you spend some time, then just the easiest one decision tree.
Go through one of the programs.
Like this three, make a like solve it, and then you make it just no need to be fine-tuned slide. Make some slide, and then we can explain. Okay, how you did that? What are the hiccups? Say for example, in any case you could not do that. Where did you reach? Okay, okay, and how you try to you can collaborate. But like if you are not in MATLAB, whatever like if it's you are in, I know it's difficult for you. Like you are working and he's here. Anyway, you can do independently or you can collaborate. It's up to that. But just try to like at least share information. So if you decide in MATLAB or any software, she is good in you are in MATLAB, you are already familiar, so you can use MATLAB toolbox. Okay. Right. Okay. So in that case, Python you can, by the way, you can check the book, and then even there is another presentation. It's on your Python. Okay. And even in the email, this one of my students, he made some basic thing. You can use it from there. Like one of my students, he like already there, like whatever he did for the presentation. Okay, so it's there. You can just use that. So now tell me, like, what do you feel like? What is comment? Like, what should you do? Should you still have some time? Yes, around 10 minutes. Let me let's answer the numbers. Okay. Let me put like what do you call? Say to the end. To the end means say the problem you are dealing, for example. So let me see. Let me solve this hard problem. This one. So here she is looking for say trip generation, breaking the trip generation. So for you, what you need to know what is the input. What is the input? What is the output? Okay. So this is step 1 for example. And then step 2 will be, what could be the step 2 based on our example till now? What could be the step 2? Training and testing, split the data. Training, say testing, split the data. Okay. And if you say number 3 is build a model, for example. So in the model, what you can have? You can have decision tree, you can have say AM example. Okay? And then number 4, evaluate. Evaluate, good or bad. So you should have a matrix, say root-mean scalar, RMSE, okay, mean, absolute, percentage, whatever. Okay, this is the matrix. So that you see that okay, how is doing for training and testing data, training and testing data. Okay, how good is the way? Then you can. So for example, you can tune the hyperparameters. You can tune the hyperparameters, or you can use different model. Okay, so you can. But if you can tune the hyperparameters by using meta-heuristic, so it's like you are making it, what do you call, more like academically interesting, objective, because you might by trial and error you might miss some hyperparameters. Okay, so the hyperparameter, by the way, this also not, you see things are really simple. If you want to use the hyperparameter optimization, you see maybe very good start is Bayesian optimization. Bayesian optimization. Let me understand. Don't get panicked with the name. Say for example, meta-heuristic. Before meta-heuristic, you can take, like for example, you can, what could be the combination? You can randomly select some of them, and then you can develop the model. But this one, it will try to optimize. Okay, Bayesian optimization. Interesting, with the, like, implementation of even this whole thing in Python is not a big deal. Earlier, like it was maybe like difficult. But these days, this whole thing maybe if you search it, maybe if you are good in research, you'll find it immediately. Okay, you just need to change your data set, and then some what do you call it? Some fixing some problems here and there, and that's it. Even the whole thing in the Python. Okay, it's not a big deal. You see, it's not, but it's a good achievement. You have a meta-heuristic which is finding the hyperparameters, but you have to know that hyperparameters. I said hyperparameters. So neural network, it will include activation function, number of layers, hidden layer, number of neurons in hidden layer, learning algorithm, learning rate, so many things. But this is already there. If you search it, you'll find it. It's like everything is there. Just like you have to find it, and then you have to you have to optimize that. So ensemble model, there are different kinds of ensemble model. So different kinds of ensemble models. One is like, I will not go that deep, but you can say you can subset the data, create different model, and then combine it. Okay. And another approach, get one model is used, it's making mistakes, take the input and also error and put it in the another model. Okay. So this is like, if for publication, for example, in the ensemble model, there are some recent model. You have to use this kind. This is like boosting, say, what do you call? This is like for if you are working for even for publication, okay? You see, and then what do you call gradient? This is a gradient boosting. Okay. This is light. Boosting. What is gradient boosting? So there are many techniques you can use. Okay, what he is doing is not using one decision tree. It's using many decision tree. Okay, except for decision tree. Like decision tree is one decision tree, and then the forest is many decision tree, and then this is also like usually for different kind of decision tree. Okay. So, and you can also this what do you call this? If you need to some parameter, also you can use also hyperparameter optimization using meta-heuristic. But even if you implement it, if you can implement any simple model, I think this is like a good start. Okay, it's a good start. And you have any comments, suggestions? I will have another class next class.
So we are only having 2 sessions with you.
Yes. But if you want to know more, probably I can you can keep in touch. You might email me. I'll try to share more resources. Or if you have any specific problem, you can contact me. No problem. But do your part. You got the point. Don't ask me a silly question. All question is good, but spend at least some time. Then ask me question. You got the point. Don't tell me that how to implement it in the neural network. Search it, spend some time, and then it's okay. I implemented. I am having this challenge. How to solve this? Then this fine. Any comment?
I have a question. You said that you have to make it something to change when we change the model.
Yes.
Okay, so usually what they do is that when you come with utility function using the data that you are acquiring to the data with the utility function.
No. This is what you're talking is logistic regression. Logistic regression have a utility function, but in the neural network, no need to put a utility function. Just plug the input,
Okay, so I will give it the input.
and the output is the active generation. That's it.